This topic will be about properties of exponents again, but the only thing that's different is we're working with fractional exponents. Now, aside from the fact that it just means your exponents won't be integers, they'll be fractions, nothing else changes. The same properties still apply, my same hints and suggestions still apply. So let's refresh our memories on what the properties were. There are 5 of them. The first one we typically talk about is the product property, which says if you have like bases and you're multiplying, you can merge them together as long as you add the exponents. We have the quotient property, which says the exact opposite. If you have like bases and you're dividing, you can merge them together by subtracting the exponents, top minus bottom. You have the power property, which says if you see exponents outside a set of parentheses, you can distribute or multiply the outside exponents to the inside exponents. You have the negative exponent rule, which says if your base has a negative exponent, all that negative tells you to do is flip the base, no matter if you start on top or if you start on the bottom. And then last but not least, the zero exponent rule, which says almost anything to the 0 power is 1. When it comes to simplifying expressions, I do offer a 3-stage hint. You don't have to do this. You could certainly go your own path or blend or do multiple steps at once. But I highly suggest, if we know we struggle with this, if we make a lot of mistakes, that we take things slow and steady with these suggestions. So when I simplify rational expressions, I always try to break down parentheses first, typically using the power rule or the power property. Once I do that, I simplify the numerator and denominator separately. So don't look at the big picture, break it up into smaller pieces. And this usually means we're going to use the product property. And then only when the numerator and denominator is completely simplified, you apply the quotient property if needed. So this is what we did in the previous topics when we did one variable or multiple variables. The only thing that's different about this topic is, you might have fractional exponents, but the idea, the technique, the skills are 100% the same. You just have to be comfortable adding and subtracting fractions. So let's do a couple of examples just so we can have something in our notes. Suppose I ask you to simplify let's do something really ugly looking. Parentheses, fraction bar, 4y cubed, z to the 2/3 over x to the 1/2 power, raised to the 2nd power, times another parentheses, x to the -3, y to the 6, over 8z to the 4, raised to the 1/3 power. Now I know at first glance this is very intimidating, but take it slow and steady. Let's use our suggestions in order. The first suggestion is to break down the parentheses by multiplying or distributing the outer exponents to all the inner exponents. Remember, every single base should have an exponent. Say, for example, this 4 here. If you don't see it, there's always a 1 exponent. This 8 here, if we don't see it, there's always a 1 there. So let's go ahead and distribute all the exponents out. Let's work with the left parentheses. So distribute the 2 here. That gives us 4 squared. Distribute this 2 here. That gives us y to the 6. Distribute this 2 here. Again, this is the only thing that's different with the fractions. You have to be comfortable with multiplying and dividing fractional numbers. So if you're not comfortable multiplying, dividing fractional numbers, I'm sorry, there's no way around it. We need to get comfortable. So 2/3 times 2 is z to the 4/3 over 2 times 1/2 is x to the 1. Times, let's go ahead and distribute the other exponents, this 1/3 here. So 1/3 times -3 is x to -1. 1/3 times 6 is y squared. 1/3 times 1 is 8 to the 1/3. And 1/3 times 4 is z to the 4/3. Second suggestions, I know it looks ugly, but let's just keep going on. Second suggestion is to do the numerator and denominator separately. So we're going to just work with the numerator separately, and then we're going to work with the denominator separately. So let's just work with the top here. So let's work with this guy here first. So we have this 4 here. He's a regular number, and he's the only regular number. So there's nothing I can do with him. So I'll just leave him alone. Let's go in alphabetical order. This x here, he's off by himself. There's no more x's on top. So I'll just go ahead and copy him down. Move on to the y's. We got 2 y's, so I can apply the multiplication rule. And according to the multiplication rule, when you multiply like bases, you add the exponents. For the y, we're going to do 6 plus 2 gives us 8. And then on the top, this z is by himself, so just copy him down. Now let's work with the denominator. The denominator, this is the only regular number. Nothing I can do with him, so let's just copy him down. X, this is the only x. Copy him down. This is the only z. Copy him down. Right. So hopefully you guys can see it's not that bad. We can actually do this. Now, then we apply the quotient rule. So these regular numbers, they're not the like bases, so I'll just leave them alone. So 4 squared, 8 to the 1/3. Move on to the x's here. So let's subtract the exponents, top minus bottom. -1 minus 1. This y is by himself, so I'll leave him alone. So you have y to the 8. And then I hope everyone can see that the z's here, I don't need to do any subtraction. They just naturally cancel out. So I'll just go ahead and they cancel out. So then we have 4 squared, x to the -2, y 8, 8 to the 1/3 power. And then we do have this negative exponent, so we're going to flip the x instead from the top to the bottom. And there we go. We simplified it. Now, if you're to check the answer key, this is not what it's going to say, because when it comes to regular numbers, I sort of expect you to figure them out. So the 4 squared, that shouldn't be difficult. We should know our squares. 4 squared is 16. But this 8 to the 1/3 power. So here's some scratch work here. We need to remember that fractional exponents are the same thing as radicals. So since this denominator is a 3, 8 to the 1/3 power is the same thing as the cube root of 8. So we need to know our radicals as well. So the cube root of 8 is 2. So this 8 to the 1/3 is actually 2. And now we can simplify this guy as normal. What's 16 divided by 2 reduced to? Of course, it's going to be 8. So that is your most simplified, nice looking answer. So you can see here how this topic, yeah, it may seem lengthy if you look at our work here, but I made it lengthy because I took it one step at a time. It might be a lot of writing, but I hope it's very straightforward, very minimum chances to make a mistake. As you get better at these, you can start skipping steps. You can do multiple steps at once, but I highly suggest we do take the time. We do take the paper of all the writing down. Take it slow and steady until we get more confident and competent with this topic. Let me just do one more random example just so you have more examples in your notebooks. So I'm just going to pick one example by random. Let's do this one here. Say, 9st. I'm not going to use s's and t's. I'll use x's and y's because my s's look like 5. 9xy to the 3 halves powers over 27x cubed y to the negative 4 to the 2/3 powers times 3x to the negative 2 over 4y to the 1/3 power raised to the negative 1 power. Very complicated, ugly looking. Let's just do the same 3 suggestions. Suggestion number 1, break down the parentheses with the power rule. So I'm going to distribute this 3 halves exponents. I'm going to distribute this 3 halves exponents. Distribute y to the 3 halves exponents. I'm going to distribute this 2/3 exponents. 27 to the 2/3. Distribute this 2/3 exponent, x to the 2. Distribute this 2/3 exponent, y to the negative 8/3. Times, distribute this exponent of negative 1, 3 to the negative 1. Distribute x to the positive 2. Distribute 4 to the negative 1. Distribute y to the negative 1/3. Next, I'll go ahead and simplify the tops here. So just work the top and bottom separately. So we do have multiple regular numbers, this guy here and this guy here. But since one is a 9, the other's a 3, there's really not much I can do with him now. So I'll just go ahead and just copy them down. We'll save them for later. I have multiple x's here, so let's apply the power rule. When I multiply, you add the exponents. So I have to do 3 halves plus 2. And again, this is just knowing how to add and subtract fractions. So if, I'm going to leave this to you to figure out. You just need to be comfortable adding and subtracting fractions. Heck, just use a calculator if you're not comfortable. So if you were to add 3 halves with 2 correctly, you should get 7 halves. And then this y is by himself, so we'll just copy him down. Okay. Now let's work the denominator. Again, we have multiple regular numbers, there's 27 and 4, but they're different, so there's not much I can do with them now. So I'll just go ahead and copy them down. 27 to the 2/3 power, 4 to the negative 1 power. This x is by himself in the bottom, so I'll just copy him down. And then I have these 2 y's, so I'm going to add them together. So we have to do negative 8/3 plus negative 1/3, which is going to give us a negative 3. Now I'm going to do the quotient rule, which is the subtracting like bases. All of these regular numbers here we'll take care of later because they're all different. So I'm just going to copy them down as is. We'll take care of them later. So with the x's here, you've got to subtract the exponents, top minus bottom. And again, we're doing 7 halves minus 2. You just got to know how to add and subtract fractions. But if you do that correctly, that's going to give you a 3 halves power. And then let's go ahead and subtract these guys here. So that's 3 halves minus a negative 3. So that's going to be a y to the 9 halves power. We do have some negative exponents. So this guy here is negative. This guy here has a negative exponent. So what that means is we're going to flip them. So since this 3 has a negative exponent, he flips to the bottom. Since this 4 has a negative exponent, he flips to the top. So far right now, this is what we have. It's not going to be our final answer because we got to take care of those regular numbers. But that's what we have. So now we have to take care of 9 to the 3 halves powers. And again, fractional exponents are just radicals. So since the denominator is 2, that's simply the square root of 9. But I do have a numerator of 3, so you cube it. So that's going to give us a 27. And then we have a 27 to the 2/3 power. The denominator is 3, so that's the cube root. The exponent, or the numerator, is a 2, so that means my power is a square. So if you figure him out, that'll give you a 9. So we have 27 times 4, x to the 3 halves powers, y to the 9 halves powers, over 9 times 3. And you go ahead and do the math on this guy. You do all the cancelization. You multiply, cancel. It turns out that 9 times 3 and 27 will cancel out, and you're left with 4x to the 3 halves power, y to the 9 halves power as your final answer. So this section is going to take a lot of practice. I imagine if you're going to have trouble with this, it's not going to be the properties. It's not going to be my 3 steps. It's going to be keeping things organized and dealing with the fractions. But hey, we got to overcome it. We got to be better than fractions. So that is properties of exponents with fractional exponents.